Now that we've talked about why objects move, why they start moving, why they change how they're moving, we need to actually talk about how we describe or measure that movement. And the first step along the way is talking about position, displacement, and distance. So first we have position. Position is a measure of the location of an object. Of an object in time and space. So it's the measure of the location of an object in time and space. Typically, for what we'll do for most of this unit and for most of this year is just focusing on the space part. So in colloquial language, where is it? That's what we're answering. The measurement and the units that we use, we're going to represent it with the variable x, lowercase variable x. Sometimes you'll use y and z as well, but typically it's going to be x. And the units are in meters or alternative position, right? Distance, things you can measure with a meter stick. Whoops, I put that early, so they're going to be down here. So again, the variable x, y, z are all quite common there. If we start changing our position, there's two ways to describe that. One is displacement, and this just cares about compare a straight line between initial and final. And distance is consider the path. Displacement, in case you're wondering, is a vector, and distance is a scalar. Let me actually pop back here for a second. Position is also a scalar. The location of an object is just represented by a number. We don't care about direction. There's no direction to it. You might have positive and negative positions, but in that case, the positive and negative doesn't indicate direction. It just indicates a region that you're in. It's a little weird, I know, but as we practice with it, it'll make more sense. So an example of the difference between displacement and distance, if you've got your house here, and then you've got a friend's house over here, and say there's A101 right here. If you leave your house and you travel to A101, you pick up some stuff, then you go like this and end up at your friend's house, your displacement is just this right here. But your distance is the total, like all the blocks you traveled. So going this direction, then traveling here, then traveling here, traveling across here, traveling down here, traveling here, traveling here. If you like laid down a string and then measured how long that string is, that's your distance. So displacement will often be shorter or smaller than distance. In fact, I don't think you can have a displacement no, you can't have a displacement longer than a distance, but you can have a distance that's the same as displacement. If the same situation, you went to your friend's house and came home, your displacement would be 0 because you're in the same place you started, but your distance would be however far it took you to get to your friend's house plus however far it took you to get back. So when we're talking about these changes, we use the Greek letter capital delta, which is this triangle symbol, and we say delta x. And so this means change in x. And we typically will write this as delta x equals x minus x naught, the final value minus the initial. We could also say delta v equals v minus v naught. And it doesn't matter what this is, it just means sum 1 minus an earlier position. And when calculating change, like we set up there, subtract initial from final. And in this case, the x is the final, x0 is initial. Sometimes you'll also have problems where you'll find it useful to label like x1, x2, x3, etc. And those would just be intermediate points. So the displacement from x naught to x1 would be x1 minus x naught. The displacement from the final to the initial would be x minus x naught. You could also have x3 minus x1. It's always just where you end up with minus where you started from. And then just as a note, you can say x0 or x naught. It's just, I think x naught is a slightly more British way of saying it that I picked up in university, so just to have it because of what my professor said. But if you say 0, that's totally fine. That's totally normal. So that takes care of position, displacement, and distance.